I can hear you. Assalamu alaikum.
Walaikum salam, Dr. Malak. Welcome to the webinar. Sorry, everyone, we'll be late for, give us 2 minutes and then we'll start. Assalamu alaikum. Can you hear me? My voice is clear. And can you all see the screen?
Yes, it's clear. We can see the screen.
Okay, that's great. Good evening and welcome everyone. I'd like to thank you all on behalf of the KFUPM Environmental Club for attending today's webinar. And I would like to thank Dr. Malak for accepting our request and presenting today's webinar. I'm Hussein Abu Mnassar, the founder of the Environmental Club, and I'll be your host for today. But before we dive into the main topic, I'd like to introduce the club real quick. The KFUPM Environmental Club. Our mission is to raise awareness, bring about the necessary change in attitude, and provide students with opportunities to take action in protecting, restoring, and improving the environmental quality in Saudi Arabia, King Fahd University of Petroleum and Minerals in particular. Our vision is to play and fulfill a prominent role in the 2030 vision by providing a healthy, clean, and protected environment, supporting a sustainable world for all organisms now and for future generations, based on a society living in harmony with nature. Our club leaders, our President Faisal Al-Hajari, founder and advisor Hussein Abu Mnassar, Vice President Walid Al-Zahrani, Club Secretary Turki Rashid, Digital Marketing Leader Ahmed Sharafuddin, Documentation Leader Abdurrahman Al-Yusuf, Operational Leader Hassan Flimban, Design Leader Abdullah Namla, Public Relations Salman Hamid Al-Din, and Research Leader Ahmed Al-Sulaimani. Today's webinar is titled Clean Energy Innovation in Saudi Arabia and will be presented by Dr. Malak Al-Nory, provost of Effat University. تفضلي Dr. Malak, the mic is yours. I'll just stop sharing and then you can share the screen.
All right. Assalamu alaikum wa rahmatullahi wa barakatuh. I'll share now my screen. Is it clear to you now? Hello?
Yeah, both the screen and the camera. They're both clear.
Okay. All right. Perfect. Thank you so much. Thank you for the invitation. I am humbled for the invitation, and thank you, mashallah, for the effort in your club and all these leaders of today and the future, inshallah. I'm very, very pleased to be here with you today. And I would like first to give an overview about myself. I am provost, as mentioned by Hussein, the provost of Effat University, means Chief Academic Officer. I like also to introduce myself as a researcher who interested in clean water and clean energy, mainly desalination topics, energy management, renewable energy, supply chain, integration of renewables into the smart grids, women in STEM, optimization modeling for the purpose of the management of the resources. I gained my PhD from Volgenau School of Engineering from George Mason University in Washington, D.C. area. I was the first Ibn Khaldun Fellow at the Center for Clean Water and Clean Energy, which is an initiative by KFUPM and MIT. I spent 3 years as a postdoctoral fellow in MIT, and then visiting scholar in the MIT Mechanical Engineering Department since 2016 until the present time. I'm also honored for 2 major achievements in my career, which is appointment as a Clean Energy Education and Empowerment C3E International Ambassador, representing Saudi Arabia, and Saudi Arabia Mission Innovation Champion of 2020, which is Mission Innovation is a global initiative from 21 countries and all the European Commission in order to accelerate clean energy in the world. Okay. The objective of my talk today is to provide you with an overview of clean energy scene. What is the Kingdom of Saudi Arabia stand, the global issues, the efforts in addressing climate change and environmental issues, and the carbon emissions. Also to show you or share with you some opportunities that help you to contribute to the clean energy field. I'd like to start, and before I start, actually, I'd like to just mention some of the terms that's used in the field, like clean energy, sustainable, alternative energy, renewable energy, green energy. We hear all these terms been used interchangeably. There's slight differences between these terms. Mainly clean energy is derived from emission sources. This includes the nuclear energy as well. And in addition to energy that's saved through energy efficiency. Whereas renewable energy focus on energy that is regenerative from resources that actually naturally available and these can be generated over a short period of time and cannot be entirely depleted. So that's the main difference. Okay, I'll use the arrows here. Okay, I would like to bring also to our attention the recent announcement by His Royal Highness Prince Abdulaziz bin Salman, the Minister of Energy, the announcement that 50% of electricity in Saudi Arabia is going to be generated from renewable energy very soon by 2030. This is a major announcement and achievement and brought everyone attention to the importance and the direction that the kingdom is taking. Also, the recently approved and endorsed communique, which is the result of the G20 efforts and the meetings by the G20 leaders. The communique itself, which is the final product that comes as an agreement from all the G20 leaders, brought in several locations the importance of addressing climate change issues and the clean energy. And as you see here, this is one quote by the minister himself and a statement from the communique that G20 ministers of energy, they believe that access to cleaner, more sustainable and more affordable energy is essential to reducing global poverty, promoting economic growth. And this is achieved through diversification of energy sources, and the employment of innovative technology, innovation. How does it look like today? So up until 2019, you can see the progress towards including more renewable energy in the energy mix globally. The global installed capacity of renewable energy reached 2,500 gigawatts from all renewable energy types. Dominant to these types are the hydropower, as you see in the blue here in the chart, which is generating energy from water bodies. And this is about 50% of all renewable energy generated in the world, or installed capacity in the world. And then come in tie very close the solar energy and the wind energy with 25% each. And then only 5% remaining for the about less than 5% about the other types of bioenergy and marine energy and geothermal. But if we can look closely at the recent development, 2018, 2019, we can see who are the dominant players here. And you can see that solar is by far has been increasing in a major way, in addition to wind. Both continue to be dominating the scene of the renewable energy capacity in the world. However, this growth is interesting and exciting. However, it is really not enough by any means, because all the growth happening today in the renewable energy, it is less than 1/3 of the demand growth. So it's not the actual even demand, it's 1/3 of the growth happening on demand on energy and electricity. And if we look by sectors, how much the contribution of renewable energy in different sectors, these are the main areas of energy consumption. We can see that the highest contribution of renewable energy comes into the power sector, which is about, let me remove this so I can, sorry, okay. Which is about 26.4% from in the power sector, which is used mainly for lighting and inside buildings and different usages. And then in transportation, it is only 3% comes from renewable energy. And in thermal usages, which is cooling and heating inside a building and for the industry, is 10%. Okay. The overall, the highest percentage of renewable energy, as you can see here, comes in the power sector. However, this is the minimum contribution to the final energy consumption worldwide. And the largest energy consumption, which is 51%, comes in the thermal, which includes the heating for different purposes, whether residential or even industry. However, this is only 10%. This brings together about only 11% worldwide from the overall final energy consumption comes from renewable energy, and leaves about 80% comes still from fossil fuels, and 2% from nuclear, about 7% coming from traditional biomass energy. So achievement is being good. However, focusing on the power sector is not going to be enough to reach the climate goals. What's also happening today and calls for movement and working towards clean energy innovation. 77 countries by far, they have announced their commitments to net zero carbon emissions, meaning that all the energy consumption, all the operations within these countries will not have any type of carbon emissions, net zero carbon emissions by 2050. The balance will amount to zero. And these countries, including Saudi Arabia, realized that the importance of clean energy to combating climate change and to limiting the rise in the global temperatures up well below the 2 degrees Celsius, which is the level that is being considered causing the issues with the climate change and the rise in the global warming. The importance of energy access and security, they are key for any economic growth and sustainable development. This major progress has been made, of course, because of the advancement in the PV solar, in the lower cost of batteries, the lower cost of wind energy. All this reduced the electricity, the cost of electricity coming from renewables and electrical cars. But this development rate still not allow us to reach the goal of net zero emissions by 2050 that has been promised by these countries. And you can see from the graph here that with the current installing capacities that we have today, with the current rate of development, we will not reach net zero emission until 2070. Also, the graph shows here the different sectors that will be contributing to the reduction. So these are reductions that are going to need to happen from power generation, from using electric cars, from industry, efficiencies, and renewable energies. Okay, so the current energy infrastructure that we have today is too large and too big in order to get rid of it. So it will carry on with us for longer periods than we would hope to. So the current inefficiencies and the current energy systems that we have today and the whole infrastructure will continue with us for a longer period. And they're still very young installation that will continue. You know, installations in the energy sector continue for 50 years and so on. So these will continue with us for a longer time, which means that we can see here from the graph that by 2070, these are the technologies stages today that will contribute to the reduction of carbon emissions by 2070. So you can see that the mature technology today will contribute, of course, but it will contribute minimally, whereas early adoption will contribute about 40%, 35%, and technology that at demonstration and large prototype today will contribute in a major way to reduce the carbon emissions by 2070 to net zero emissions. So this is a report from International Energy Agency, an outlook for the future to evaluate these goals and how can we reach these goals. And the recommendation that we need to right now, as of today, bring in and roll out clean energy technologies in order to be able to utilize those towards the future. So if we work today towards creating today large prototypes, large demonstrations, then we can reach further and come closer to our climate goals. Okay. Here I wanted to also confirm, and according to the same report and study by International Energy Agency, what kind of rapid development need to happen. We need major push to build clean energy infrastructure, and these are some of the areas that we need to add to the current infrastructure in order to reach to our goal of net zero emissions by 2050. We need additions of renewable capacity to reach almost 800 gigawatt per year that need to be installation. This is as large as the largest solar park today. Every 2 days need to be added. These are the additions that we need to add. We need to add electrolyzers as much as the largest today in operation electrolyzer. Every 1 hour need to be added until 2050. And then we need to add additional carbon capturing, CO2 capturing, as much as 250 million ton CO2 per year. So we have a huge challenge ahead of us. Today, Saudi Arabia total carbon emission has fell by 26 million tons of CO2. This is indeed brought the Kingdom of Saudi Arabia to be the third fastest reducer of greenhouse gases among the top 20 countries in the world, which is the G20. And this was basically a result of carefully planned transitioning to a greener energy. So 1 second, sorry. I am a bit, hello?
Yeah, we can hear you. Just the
Great.
camera was turned off.
Okay. I think I have issues with the, all right. Okay, so as I mentioned today, the contribution of Saudi Arabia that CO2 emissions fell, and this was reported early 2019, that by 26 million ton of CO2 emissions, which brought the kingdom to be the third fastest reducer of greenhouse gas emissions from the G20 countries. This was a result of the carefully planning and for the commitment of the Kingdom of Saudi Arabia in its Vision 2030 and following the NDCs. NDCs is an important aspect showing the commitment of the Kingdom of Saudi Arabia. This was an agreement and a commitment submitted by these countries to the United Nations Framework Convention on Climate Change, the UNFCCCs. I'm sure you've heard about this, where the countries commit in certain levels of contribution to reducing the CO2 emissions. And Saudi Arabia provided certain levels expected contribution into to collaborate with other countries in order to reduce these levels. And these are called nationally determined contributions, NDCs. For each country among these 77 countries have its own NDCs. Saudi Arabia commitment and they provided. The focus was on contribution to economic diversification through energy efficiencies, renewable energies, carbon capture and utilization of gas, methane recovery and flare minimization. Also contribution to adaptation through adaptation, which is water and wastewater management, urban planning, marine protection, reduced desertification, integration of coastal zone management planning, early warning systems, and integrated water management planning. This was also within the commitment. Also, the country shows how much the level of contribution, and the advertised contribution from Kingdom of Saudi Arabia is 130 million tons of CO2 equivalent. to be avoided by 2030 annually through contribution to economic diversification and adaptation. In addition, investment of $150 million or 562.5 million. So this is a commitment for a target of investment within this area. Also here I brought in the areas that the R&D need to work on in order to promote and to bring in innovation in the area, which is this is the focus of the country. I think this is helpful for everyone to know, so we know which direction we take in order to contribute and in order to find the opportunities. Carbon management from mobile and stationary sources, CO2 utilization, carbon capture utilization and storage, transport fuels, energy efficiency, energy storage, and renewables, mainly focusing on solar and wind. Okay, so how this contribution and this reduction in the CO2 emissions happened? What did the country do in order to achieve this number? Mainly stronger energy efficiency and regulations and energy pricing reforms. I'm sure you are aware of Saudi Energy Efficiency Center, or at least if you're not aware of the name, Kafa'at al-Taqa or SEEK, you're aware of the tags that we see on all the appliances that we buy, the colorful ones, green and yellow. And when you buy a car, when you buy any appliances, you see these tags telling you how efficient is this. This is one of the programs actually to monitor and to enhance the energy efficiency in the country. And you've seen how Kafa'a was very, very active in the recent years. This is mainly, we wanted to address the energy consumption in three main areas of consumption in the country, similar to other countries: transportation, building, and industry. These are the three main areas that we actually consume largely the energy. In transport sector, it accounts for 21% of the country total energy consumption. This is about 1 million barrels of oil equivalent per day. And the emission here fell by 19% in 2018. This is basically of all these programs and regulations on the energy efficiency. In the industry sector, sorry, the target was to improve the energy intensity by 1% per year. That has been achieved. In the buildings sector, this is the second largest consumer of energy in the kingdom, and it's accounting for about 29%. And it introduced stronger building codes, including insulation standards, air conditioning standards, among many other programs. Also, we have seen reform of energy prices. The kingdom is moving away from pricing based on the energy production cost to or fuel production cost to benchmarking with international pricing of energy. And among these programs also the Citizens Account Program, which paid more than 11 billion in dollars for direct payments for the citizens, اللي هو حساب المواطن. Okay. Another important front addressing the country NDCs, the nationally determined contributions towards climate change, is the investment in clean energy projects. In 2017, King Salman Renewable Energy Initiative was announced, and this emerged from it the National Renewable Energy Program, NREP, برنامج الوطني للطاقة المتجددة, and Renewable Energy Projects Development Office, RIPTO. The focus was to provide public-private partnerships in order to develop the sector, guiding policy to create global competitive and locally based technology hub, and contributing to the kingdom energy transition and the environmental commitments. the areas that have been focused on the solar PV, waste to energy, wind, and solar CSP. REP2 also started an ambitious program to install renewable projects in mainly solar and wind. This is the main focus as of this phase. First city-scale solar energy project was in Skaka, and that was awarded 2018 with a world record at that time of levelized cost of energy, which is 2.34 US dollar. And the wind project is in Dawmat al-Jandal, 400 megawatt onshore wind with a levelized cost of 2.13 US dollar, also a world record today. And these covering together 45,000 home and 70,000 residential homes will be supplied by power from these two projects, also contributing to more than about 2,000 jobs in the sector and investment in the carbon emission reductions as well. Here I would like to bring to our attention the concept of the circular economy. And this concept, if you've been paying attention to what's been proposed in the G20 activities and recently by the Ministry of Energy and all the main players in the field, is the circular economy concept. The concept has been around for about 10 years. It's changing the world in a very profound ways. And the government and societies have been utilizing this concept to bring in opportunities and addressing their challenges. It is a holistic concept, yani from cradle to grave, all the way to evaluation of the whole society and the economic activities and the environmental dimensions of resource utilization and waste production and utilization. So basically bringing the economy into full circle as a closed loop system where every resource is being used and reused and utilized. There is no waste at all, zero waste out of this system. Right now, only 9%, sorry, only 9% of our extracted natural resources currently are being reused. And the potential is enormous if we utilize this concept to reintroduce these resources into the economy again and take the waste out of the current linear take and make and waste extractive industrial model. The connection between the environment and the outbreaks of infectious diseases have been recognized for longer time, but recently with the COVID-19 pandemic, was clear how this connection is very important, how waste generated from industry and from other processes are actually harming the system that we live in and harming the atmosphere and causing all this kind of diseases and health issues for everyone. This concept has been, again, the circular economy has been heavily studied and utilized and has its many applications, even in the kingdom, including carbon capture and sequestration from industrial processes, brine management, which is the water, the byproduct that comes from the water treatment, is been also reused. Water and power cogeneration by exploiting steam from power to use it for desalinated water, in increasing hydrocarbon recovery while reducing environmental and economic costs related to oil reservoirs access and production. Also using computationally driven methodologies and tools and resources to speed up processes and make it more efficient, especially for the biological discovery. This has been already utilized. In addition to that, the kingdom recently, also through the G20, I'm bringing lots of examples because this is a very relevant and recent to what's happening and discussion and we've been involved in recently and actually up until now. The model that proposed by Saudi Arabia and endorsed by the G20 leaders during the summit just a few days ago, the circular carbon economy. So it includes carbon as the heart of this model, where it is an innovative model brought in by Saudi Arabia. This to reduce carbon accumulation in the atmosphere through 4 R's. First, reducing the amount of carbon entering the economy, then reusing carbon as an input to create valuable feedstocks and fuels, also recycling carbon through the natural carbon cycle, and removing excess carbon from the atmosphere. So you can see how within a certain activity, carbon is being utilized back into the same activity, and that's the example that you see here on the screen, by being captured actually from the different activities from the different resources. Here is another example of innovative solutions to our problems, which is the increasing demand on fresh water in a very dry environment and extensive use of fossil fuels currently for water desalination. This is the situation that we have today. We have today dry areas. We don't have any freshwater bodies. We have to bring in water from the, we have overused our aquifers and natural resources and now and non-renewable resources, and now we have to figure out how to continue producing fresh water. Of course, we use desalination, but this is a very energy intensive process. And one of the solutions is investigate I did, which is I worked on, is investigating water desalination consumption, which basically this whole process amounts to 100 more than 100 billion cubic meter a day that has been produced by desalination. Fresh water been produced by desalination every day globally. And even if we think about this amount of in this process, the amount of energy needed for this process, even if we use the best and the most efficient technology, we will need about 190,000 tons per day. And we will be producing 190,000 tons per day in CO2 emissions. Of course, the first thought that comes here, why don't we use solar? Yes, great. Then we can introduce a system of PV and RO, photovoltaic, and reverse osmosis. The reverse osmosis is the process that we can produce fresh water by pushing water mechanically through membrane in order to similar to filter it, bring it to desalinate it and get rid of the salts. Now, this process, even though it can rely on renewable sources, still it has its challenges. The first challenge is the capital cost. The cost will be increased now because we have two systems, not just the membrane system, we have also the photovoltaic system and the components, which adds additional cost on the capital cost. Now, with the reduction in the cost and the prices of photovoltaic, this is not very significant aspect and challenge. Another challenge is the complexity that brings in with additional photovoltaic, additional renewable energy, and additional solar and wind that brings into the energy system, brings in its own complexity, because you cannot operate this system except if you have also batteries. Batteries also still expensive economically and environmentally. Another challenge is that the PV modules and the elements used, they are still rare earth elements and only available in certain areas, not everywhere, not available freely for everyone. The issues also of brine management. What do we do with the byproduct that comes out? We pressure the water through the membranes, comes fresh water, but the other side comes even saltier water, and it includes all the dissolves. What do we do with these? There's also the processes of pre-treatment and post-treatment efficiencies, and the fouling issues of the membrane, the maintenance of these components. Within this model, I also proposed that a model for solar desalination, photovoltaic reverse osmosis system with water storage. So in order to reduce the cost of energy storage, which is batteries, and the cost, as I mentioned, economic and environmental, we can use water storage. Water storage, and I propose that we use this in Al-Khafji. This is a seawater reverse osmosis project using PV system. Provides a capacity of 60,000 cubic meter per day, already operating a few years now. It's the only fresh water for the inhabitants in Al-Khafji city. Of about 100,000 people are actually using this and rely on it for fresh water. And this is the only solar desalination plant in Saudi Arabia. The integration results in net zero emission balance. So we actually provide the additional electricity, additional energy, if not needed in the plant, can be provided back into the grid and provide additional clean energy to the system. Okay. Also, the costs are very low cost, 2 cents per kilowatt hour, as of all the advanced technologies available in this location. Okay. And among the many advantages provided by this combination or innovative solution, it also brings in a hydrogen production system. So plugging in a hydrogen production system from water using PV solar to be connected to a broad an electrolyzer that maximizes the performance of this system, with the objective of at least 10% of solar to hydrogen efficiency in the solar in the overall system. This also brings in the advantage that the additional integration of renewable energy into the smart grid or into the grid, the power grid, controlling the unfavorable variability of the renewable energy sources, the cost reduction, because now we have, the system is actually a productive system. It's actually produce energy from hydrogen. So it includes also green hydrogen component, and this will contribute to cost reduction, and in addition to net zero emissions, and overall contributing to the emission reduction in the country. As this was a study the results here that you see here, or this model was, I proposed it among a team of researchers in T20, which is Think 20, one of the engagement group of the G20, in a policy brief, cost-effective low carbon framework to manage emissions from water desalination. And we expected that cost reduction in the overall global capacity of desalination capacity will reach 1,479,000 millions or trillions in dollars, and 428,000 tons per day from emission reduction globally. Okay, this is, I mentioned that it's how the using also the green hydrogen production system component would increase the efficiency of the system. Here's some more examples of related issues that worth investigation. For example, integration of renewable generation and desalination. The integration of systems, it's worth looking at because it increases complexity. However, it brings in innovative solutions customized to our needs. As I mentioned in my example, using water desalination by water storage as energy storage is an innovative way to think about even bringing not just clean energy, but also clean storage, energy storage as well. Also, water and energy management models to support the planning and evaluation of the different technologies. We have now many technologies, large number of technologies. How do we integrate hybrid systems from different technologies in order to bring in the best solution? Renewable energy sources planning. So we have even different renewable energy sources, and how do we bring in the best energy mix according to our plans? How do we carefully integrate different sources over the time period in order to achieve best efficiencies and to reach to our goals? As you have seen, the kingdom has been trying really hard in order to achieve the goals. Many programs have been launched, been changed, many targets has been put and then changed again. So far we have only two main projects, the SKAKA one and the Dawmat al-Jandal one of 300 and 400 megawatt, which means that there's lots of issues that needs investigation and studying to understand what are the difficulties and trying to resolve these. Also, energy storage is a major issue with clean energy and renewable energy. Definitely, we need an energy storage, but energy storage systems can be pump hydro energy storage. It could be gas storage. It can be water storage. It can be heat storage in the shape of heat. Different types of energy, which even the batteries themselves, there's different types. Which batteries types are the best? Lithium ion or different types are the best for specific usage and specific duration, short and mid and long term. Now, here I give you examples of how you can, and at more specific examples, how you can become part of this movement and contribute to the research questions and the engineering areas. So there's, you can contribute to the PV cell fundamental research. This is basic research. You can look at power system from the power systems point of view and transmission modeling, utility scale storage and battery chemistries, data sciences and AI also to decarbonize, from decarbonization, from decentralization, digitization, dust repellent and hydrophobic coating. Different questions that worth investigating. What will energy demand be in 5 years? How much solar generation should we build if any, should we use solar or not? Should we use certain type of energy? Should we go with geothermal or not? This is can be as mathematical optimization modeling. From financing point of view, what is the best type or route to finance new PV systems or hybrid PV coal gas plant? Should the government raise the electricity price or not? This is economics, microeconomics. So engineering, technology, policy, economics, finance, law, environment, computer science, mathematics, all these areas are really needed in order to contribute to this, to the innovation in this field. Finally, here I would like to mention that Effat University is a pioneer in energy engineering, and this is an invitation for all of you to look at what we have at Effat University. Okay, is this me? Sorry. We are known to be the first engineering offering the first engineering program for females in Saudi Arabia in 2008. Now the energy engineering program that started in 2017 with a concentration in renewable energy and petroleum engineering are both open to male as well. We have also installed a solar project on campus to serve as a laboratory for research and to help the students. Actually, we trained the faculty and the students themselves. They designed and installed and operate these solar projects. I myself supervised these two projects, solar PV, both of them. The first one was 20 kilowatt peak using commercial thin film modules. And the other one, the second one was 17.4 kilowatt peak, which was using special coating. And this was a collaboration with a research center in Netherlands and an industry partner, Zahid Group, Al-Taqa. Three of us, we partnered in order to train and the faculty and the students into designing, installing, and operating these systems. And these modules had very special coating, anti-dust and soiling to be suitable for the environment in Saudi Arabia, produced by a company in the Netherlands. Okay. Here last, I would like to just leave with you some key takeaways that I would like you to remember. We do need clean energy to achieve climate change goals and the economic growth and the diversification of energy sources as being the focus of the Vision 2030 and the current direction of Saudi Arabia. Also, our country has committed itself to certain goals in the shape of NDCs, and it allocated investment amounts and investment plans amounting to $150 million. This is a huge opportunity for employment and to find innovation and to provide innovation in this area. There's already fund there. We need innovative and customized solutions for our challenges. The world out there will not worry much about dust. We worry much about dust. The world out there will not worry much about desalination, high-level salinity water bodies as much as we do. So we need to look at solutions that's customized for our own needs, because this would be our problems and what we want to solve to enhance our future and the future generations. Finally, all disciplines are welcomed to contribute to this field, and almost every discipline will have its contribution that will really contribute to this innovation in this field. I think this is all what I have for you today. I hope it was beneficial and you find it helpful, and I'm ready to answer any questions.
Thank you, Dr. Malak. The presentation was really insightful and beneficial. I'm sure all attendees did benefit. Please, if you have any questions, send them on the chat, and I'll be reading them to Dr. Malak. Okay,
You
we
see
have a
that I have a screen here. It says pulse secured. Okay, this is not you, I think. There is issues here with my screen.
Oh, okay.
Okay,
We can't see
go
it.
ahead, sorry.
No,
Yeah,
it's
okay,
okay.
good.
It's okay.
Good, you don't see it. Okay.
We have our first question from Faisal Al-Utaibi. Would we consider the clean and renewable energy approaches as big a challenge for oil and gas industry thriving and consequently the country income?
Okay. Yeah, this is, should I answer now or you would like
Yeah,
to
yeah.
go on with other
No, that's
questions?
it.
Okay.
No, go ahead.
Okay. Thank you for this question. Actually, this is the first question that comes to mind and comes to me every time I give a talk or I have a discussion locally here. I really understand where is it coming from, especially that we are a country which the main economy rely on oil, whereas now whether this clean or a clean energy will create a challenge for our current systems. The reality is, and as you have seen from the slides, that the contribution is very, very low, and it will remain like this for a very long time. Even when I mentioned the 2050 goals and 2070, we're talking about still the percent. And if you remember also, when I give the definition of clean energy also includes efficiencies of using the fossil fuels and the current systems. So it includes renewables, includes net zero emissions, such as nuclear, or nuclear specifically, but also includes efficiencies from current systems. So if we have an efficient system, then we're talking about clean energy here, including even fossil fuels. And just also to confirm what I'm mentioning here is the circular carbon economy. The circular carbon economy model produced by or proposed by the Kingdom of Saudi Arabia is actually utilizing the carbon in order to enhance the overall efficiency of the system and reduces the any waste in the system, or actually eliminate all of the waste in the system. I hope this answers you to some degree.
Thank you, Dr. Malak. Our next question from Abdurrahman Al-Musafir, I guess. I hope I spelled the name right. So the question is there a future of clean nuclear energy in Saudi Arabia?
If nuclear energy will be at one point installed in Saudi Arabia? Actually, I've been in 2014, was it? Yes. There was, this is a huge discussion started there. I was among a group of faculty, researchers, and businesses and persons from industry. We visited almost all the nuclear plants in France. And this option remains open to Saudi Arabia, right? And if you are aware of the CACARE, King Abdullah Center, previously city, now Center for Atomic and Renewable Energy. So basically, renewables is within, renewables and nuclear is within the energy mix plan. We don't see exactly in the announced plans where does it fit in this map, but it's definitely one of the options that, viable options that could be used.
Okay, thank you. I forwarded to you the next question, but I read it also to the participants.
Okay.
Give me a second, yeah. what do you see the potential of biogas and biodiesel in the future?
I honestly I do not have much contribution to this area, so I cannot specifically specify, but I can look at this answer among the other resources I have, and I can get back to you on that.
Okay, thank you. Next question. It's not a question, it's like a favor. Can you comment on techniques that can be used to overcome the problem of the dust effect on the PV modules?
Yes, so I think, as I mentioned in one of the projects that we took, is the kind of there is a certain coating that can be used on the modules themselves that does not allow dust to stay on this on the module. This is one area, but also another now became almost like a traditional way is the frequent cleaning and using robots that actually move around and clean. Honestly, what's happening today is in most of the project is that manual cleaning with just water and soap. It's as simple as this. Non-chemical type of detergents to clean, very mild detergents to clean the solar cells. But this is, of course, if you have a large fields and if you want to expand on that, it is not efficient. So robots have been used in order to clean the surface of the solar modules. Certain types of coating, as I mentioned, also can be used. There is no currently there is no certain standards how to eliminate the dust issue. There's many solutions, and we're still in the try to figure out what is the best way in order to eliminate this issue. It is still a major issue with the solar fields.
Thank you. For the next question, he's saying we have seen lately the Ministry of Energy going toward energy sector restructuring. Is that direction related to circular economy and KSA initiative in G20?
I understand that the structure, of course, yes, it is not to respond to any G20, but actually, as you've seen, if you look at these, the NDCs that I shared with you, and the contributions announced by the country, it is not recent. They put these plans in 2015. Okay, so it's not just about the G20. It is a direction of the country taking responsibility as one of the top economies in the world towards what's happening today. So restructuring was required because the previous structure did not serve the commitment of the country as one of the leaders in the world, and what is the direction that the country is planning to take.
Thank you. For the next question, what do you think of wave energy to contribute to Saudi Arabia's clean energy mix?
Yeah, marine energy is also one of the possible renewable energy sources. It might be used, but currently, after many studies, the focus is on solar. This is the most effective will be for us. Wind, I believe geothermal will be next, which is bringing, utilizing the heat from bottom al-ard in order to create also to generate energy as well.
Okay, I don't know if you have enough time, but like there are so many more questions. So do we take like two more and then we end the webinar?
Okay, I think maybe later you can share the questions with me, and I can send them the answers if we have their emails, or we can post it for them somewhere.
Yeah, we can post them on our social
questions.
media accounts. We don't mind.
Okay.
That would be our pleasure.
Okay, perfect.
Okay, so this attendee is saying,
Sorry?
so this attendee is saying, thank you very much, Dr. Malak, for this insightful presentation. What do you think what do you think are the biggest challenges our country faces when it comes to decarbonization? How to tackle them, and what is your advice to our youths?
To what? Advice to what?
Our youths.
Youth. Okay, yes, definitely. Youth, the future, the present and the future, definitely. Youth have a very important role. Um, it has been, this is worldwide, not just in the Kingdom of Saudi Arabia. Youth have now much more awareness, and they have the mission. Most of them, they are aware about environmental issues and willing to contribute to supporting this mission. So youth have the major role because they are the leaders of the future. Youth have the role of bringing an innovation to the sector. Usually innovation comes from younger generations, thinking through how do we bring in new things into older people just used to do things in the same way and just used to it and keep doing it, and they cannot think of new things. But new things usually come from youth. The major, at the beginning of the question was, what is the issue, what is the major challenges for decarbonization? The major challenge that we will have here in the country is, of course, the existing infrastructure that we have relied on. Existing infrastructure includes not just the actual system and the network and the type of, but also the regulations. We will have to be changing and making changes for everything, and this is what's happening, as we have seen. All these programs that we don't, it is not linked for us, we just see the programs, but actually they're all fit very nicely into a very neat plan, into attacking the issue from different areas in order to reach to our goals. So every single person can contribute to decarbonization by simply minimizing the waste of our resources, whatever type of resources, even napkins. If we use those, you use a lot of those, then the country has to produce more to meet our demand. So the lower demands we have on resources, then overall we are helping to decarbonize the world around us. There is a very nice guide from UN. I think I will share this with the audience about how each one of us can contribute to the SDGs, which is the Sustainable Development Goals of the world by 2050. Every person can contribute to each one of these by very simple things that you can do during your day.
Thank you, Dr. Malak. And now we'll be taking our last question. If zero emission is achieved in 2050, what will happen to fossil fuels?
Okay, what we mean by achieving zero emission in 2050 is reaching the complete efficiency. Does not mean at all that no more fossil fuels will be used. But in a most efficient way, where we don't emit CO2 and leave it. When we emit CO2, we actually capture it and use this CO2 back into the industry to generate energy in the industry again, using the carbons. So this is the idea, to create a full closed loop and full cycle economy where every resource is utilized again and again and again.
Okay, thank you, Dr. Malak. Thank you for answering all these questions. I'm sure they all benefited, and the remaining questions, I'll be sending them to you on your email or on your way of contacting you. And we're looking forward to seeing all the participants in our next webinar. And we look forward to collaborating with you again. next semester,
Thank you so
inshallah.
much. Thank you for the invitation, and I hope it was beneficial for the participants. And I hope to hear from you again and connect with you some future events, inshallah. Thank you so much.